All right, report outs.
Our team developed the donor tracker. This is a very intuitive and reliable way for you to track donations. So as actors, we have here the donors, the NGOs, and auditors. The process is quite simple, but there's one thing that's pretty important, we guess. It's that every donation is contingent upon the fact that the NGO should be able to prove its obligations by different sorts of data, depending on how the project evolves. So the donor should make a payment, not the full amount that was required, but only a part. The NGO should receive it, implement it, then gather evidence that allows to see if the payment was actually used for what it was supposed to. The auditor is coming in to audit in, and then send a report to the donor who should verify this report. Dependent on whether it's in compliance or not, the NGO should receive money or end up in jail.
All right, good stuff. So we've got like, so over here on the left, you've got the actors on the top, donor, NGO, and auditor. We have the actions, payment, provide receipt, audit. We have the data. That would be like the data in an invoice and billing, receipts, timelines, and some photos perhaps. Auditors provide reports, of course, and sometimes they note exceptions and things like that. And then over here we have the swim lane diagram. So what we're looking for in a swim lane diagram is role separation. So on the top, like lane by lane, we got roles. So we got donor on a role, NGO on a role, auditor on a role. And then we can see in a sense, it's another way to do the actions and sequences with arrows that show basically like froms and tos and exception conditions. Very engineerable. I'm going to say that's good. Any questions or comments on this use case? Like, let's say like you were just being like on the fly, like put on a team that was responsible for like kind of creating the system. What are the questions? Yeah, Laura.
If this could be a blockchain process,
It should be a blockchain.
then why do we need an evidence if everybody could just go and access in the lab?
Well, we haven't discussed if it's an open or a closed blockchain. Who's going to have access to that? So.
Yeah, and then also that evidence when they're executing, it could be that the corporate donation has been for supplies to build and construct a water tower. So it's not just
of the application.
yeah. So it's not just about purchasing those construction items, but it's about actually meeting that timeline in the contingency agreement for the donation. Because if they purchased it, we don't want them sitting for the next 3 years. We want them to quickly build whatever it is that our contingency has provided for.
Yeah, so a great deal of information and data that would be so-called off-chain, but happening in the real world in a warehouse and on a construction site, hence things like photos. And just one, and I had one question, which is, what's an example of the type of evidence or data that you might be seeking? Like, just name like 2 or 3 that come to mind.
Yeah, sure. Pictures, timelines, or purchase orders of raw materials they're employing to this.
Yeah?
Certificates of completion.
Yeah.
Construction.
Okay, great. So like luckily, some of the data that you noted would also, some of the data that you noted would be some of the evidence. Okay, and one more question. Yep.
So,
Nice one.
what do you think about the auditors also certifying with a kind of identical that such a project was accomplished? So, for next due diligences, they could just go for this identical, that is certifying that people have previously. Just thinking about like creating a kind of reputation log for those different actors.
Any thoughts?
Yeah, well, it could be interesting for you to have like accredited partners or somewhat people who always do the construction because they're reliable and so on and so forth.
Right, especially in a nation that's corrupt.
Yeah. I mean, this is, right now, a lot of grants, foundations, program offices and others will audit and review grants, maybe every year, sometimes every 2 or 3 years, and so on. What's so cool about this is that it would let donors, foundations, or so on pay for performance, but in a more real-time basis. So that if an NGO is being very successful, let's say building out schools, they're supposed to build out, and it's accelerating, they're throttling down, throttling up what they're doing, you could have kind of a much more real-time, ramping up of the grant making, and you essentially allow the grant cycle and the donor cycle to pay for performance, which it arguably does not do well right now.
Good stuff. And I could almost imagine doing some performance, especially if you're like, you were saying, like, if they're long-time trusted partners, some of the savings that you could get from implementing the system over time could go to finance the system and maybe, you know, price concessions and things over time.
And actually, those savings can be used as incentives.
Yeah,
Yeah, you
Yeah,
can design,
discounts.
you can design tipping point grants too, as if, you know, one foundation and so on, but then you have a bunch of individuals, and they know if I give right now, it'll provide the last window to finish this school, and so on. It can provide an incentive to trigger the action, and so on. And so it's yeah, pay for performance. It's awesome.
yeah, I like that word completion. Okay, nice work, team donor. Thank you. Good work. All right, thank you. Okay, so let's do team Crypto Kitties. Is it next?
Well,
Okay. All right.
we're kind of team Identicons, but we were
Team
definitely
Identicons?
inspired
Okay,
by
who's
the
on the
Crypto
team?
Kitties.
Okay, you at least have to stand there. You don't have to do anything.
Now, are you manufacturing the kitties? Is that what
Well, so we generalized the use case down so that you could have these as building blocks that could be applied in other contexts.
You can be on this side.
And so we have it from manufacturer all the way down to consumer. And the actors that we've got are the manufacturer, the distributor, the retailer, and the consumer. The action would include design of the nodes, the push-pull throughout the marketplace. So that would be going from apps to wallets, and being cryptographically confirmed on a blockchain and creating the identicons. And then it would go back and forth once there's a receipt from the buyer to the seller. And we broke it out into swim lanes like this, and to get it to the consumer, it has to kind of go through this cool, weird maze. But the issue that we're really trying to solve, the provenance issue, we tried to represent with a very simple identicon example where we have, this would be the identicon that the consumer receives, so it's got the 3 slashes in the vertical line. That gets generated by combining the previous 2 identicons from the retailer and the distributor. And so by going through each of these and checking to see on a ledger of some sort, blockchain or otherwise, whether or not that each of those steps had taken place previously in time, you can get back all the way to the manufacturer who has just a T. And it also does cool things like confirm differential privacy so that you're not getting more data out there than you need to.
Selective disclosure, so
Yeah,
called.
selective disclosure, sorry.
So I want to show them just the cat's tail.
Just
Right.
just the cat's tail. But,
I want the cat's meow.
and then we indicated each time one of these identicon QR codes would be generated with a square in the swim lane diagram.
Very nice. Nice iconography. Okay, so any questions or comments on that?
It's very similar to the donut tracker.
Yep. But you focused in, I think, appropriately on those nexus points when an identicon could be minted and printed,
Yeah.
and like inexorably or immutably stitched
Yep.
to a transactional event.
And we even ran
Like we should do.
Of I threw my wallet hash value into the identicon generator, and we played around with those already. So.
You know the identicons you're talking about? Okay, of course you do. All right. We just discovered them a few days ago, and I can't stop playing with them. They're so cute. Okay, so are we good? Oh, question, Ilan? Okay. All right. So that's okay. So okay. Yeah. So no, we'll do the. Yeah. So that's an identicon.
It's amazing that the.
So
It's like
there's the
completely unique
there's the
for any
hash
amount of
value.
data. All right. So let's hear it for Team
Smart contract use.
Team Crypto Kitties. All right. Nice work. Really good work. Because a Crypto Kitty's like an identicon, maybe. It is actually. Okay. How about Team Battery Transitive Battery? Household of the future.
Nano microgrid.
Okay.
It's like a nano. It is a nano microgrid.
Transactive energy. yes.
Right. It's not a verb.
Is nano microgrid? Is that?
Yeah, you can
Yeah,
microgrid,
okay, yeah.
you can have a nano campus district microgrid, so they come in different sizes.
Every campus should have one.
So, our use case is a residential solar power unit, we'll call it a household.
Okay.
And the household can either use the power, store it, or sell it. So we have a couple things. We have the operator, and they can choose to sell it or store it, and then you can put it to your neighbor, your buyer, or put it in the network. Let's see, the business thing would be using it. Legal is the transfer agreement. How are we gonna do this? We were talking about, so there could be different thresholds for something. So it could be, just availability. If I'm not home, I'll sell the power to my neighbors. It could be something like, how do we price it? Do we wanna make it, we wanna undercut the current rates, or do we wanna, there's something, for example, we could, our neighbors are very nice, they've been babysitting.
Right.
Mow the lawn, we give them our power, or we give them a better rate, or we charge them more.
Right, kilowatt
Either
per
way.
diaper.
Yeah, exactly, yeah.
About the bartering
Let's see here,
implications
so,
of what it could allow.
let's see.
Do we have some like external data that we're getting at some point? I don't know, pricing?
External data, so yeah, we could poll the grid and see, or rather the local provider, and see the current pricing. And then also there are ways to expand that outward to go and even look at other providers. What if we do coal versus gas or?
Cool. All
And then
right.
we were also, one
Yeah.
last thing was
Yeah.
that we were
Thank you.
talking about analyzing data home, when you're home, not predicting in the future of whether you'd need more or less, or whether you would be making more money or spending more money that month based on analyzing your data from previous usage.
Great, so some predictive analytics and maybe some help with resource planning, and just planning.
Right. And even like what you could expect your neighbors to need and want from you if you're selling it.
Right, so maybe you share some of that stuff for the outputs of those calculations on a neighborhood-wide network, a nanny, neighbor area network infrastructure. And hence the diapers will take care of themselves. Okay, so any questions or comments or new ideas on, what do you call yourselves?
Neighborhood Nano Network.
Okay, on the neighbor nano nanny network?
Nano node.
Nano?
Nice.
No? Okay, let's hear it. Good work. I like it. Especially I like the fact that, I guess it's partly owing to Chris's concept, or someone's concept, but the idea of putting it on a household scale is something that makes it much more comprehensible. And eventually with all our systems and smart homes and everything else, we're going to actually want to think about the modern version of home economics. Will be actually beginning to do some financial modeling on this stuff. And QuickBooks isn't going to do it yet. They could. But for right now, we can hack it in MIT.
Here's the example I give you. Like right now, if you want to process media content, you buy a smart TV. You can pull up Hulu, pull up Netflix, pull up Amazon. You can get your cable or satellite provider. You can watch it in any number of ways, and that's where the energy world is going to. That you have just a ton of different service options, just like you have content options.
Here. Yeah, I would love to do this for all my information networks. Okay, so I think we've got one more. It's Team Puerto Rico? Puerto Rican Microgrid. Okay, who's on the team? TMA's left? Okay, come on. All right, so let's find out about the last one. Puerto Rico Microgrid ode to Michael Casey.
Correct.
Hit it.
I love it.
We do. We really do.
So basically you have the retail consumer, and you have the microgrid developer. And in this model, we're basically saying that the developer actually is kind of like leasing out the total equipment, and controlling the grid basically, so the consumer doesn't have to worry about things. So then there's generation and power, distribution, maintenance, purchasing within that system. Then to create the kind of blockchain idea is that you have, you know the information if the energy was produced, yes or no. Do you have to get the public utilities involved if there's not enough power coming into the system?
It's like buy from the grid, so-called.
Right, yeah, and then the consumer would request the power, and then once payment was made, the power would come through. If the extra energy was being created by the microgrid, it could sell it back to the utility. So yeah, that's the overall model.
Cool. All right, so, name the actors again?
Right, so the consumer, the microgrid developer, and the public utility.
Okay. And by public utility, that would be like the person that you'd be buying or selling energy to?
Just the.
Or a regulator?
Yeah, whoever was there
It'd be like,
before you built the microgrid.
WGL,
Very
energy.
inspired.
No,
of
no,
Pepco.
Yeah.
But then
Okay.
you also have the option to sell that to the wholesale power market, if you're in one as well. That's, I guess, what I'm calling the public
Yeah.
utility.
Oh, okay, good. And the core actions, we're going to just rattle them off.
Generation, distribution, and maintenance. I think we have one more there.
Purchasing.
And purchasing. Okay, great. So then so those are all actually replete with legal.
No storage?
What?
No storage? You don't store?
Okay, so we've gone naturally into questions. How about storage?
That's a good point. Sure, I guess you could decide, is the consumer
Should
can
be
store it on site? Is
Yeah.
the
Would that be a
developer
typical
gonna
thing,
create a
Chris?
storage system?
It is, and a lot of it is just dependent on the tariff environment you're in. If you have the opportunity to have, time of use rates where, peak off peak at least on the pricing, that allows you to arbitrage with storage systems from different pricing conditions throughout the day.
Love it. And so in a very good example of what we like to call agile development, storage, right there. Da-da-da. And that's why we hack together. All right, any other questions or comments on all of that? Anything? No? Okay, well, let's
So,
hear.
wait,
Oh,
so
whoa,
this-
wait.
This system kind of fits into, that could like nest inside of that, like a Russian doll.
Right.
So those are, I think you talked about the primitive of the system, which is also interesting about the blockchain, is that we can come up with a certain very basic primitive under which you overlay some applications that are sector specific.
And that's what,
Yeah.
being able to encrypt and hash in, having a blockchain. I mean, part of, where some of my clients and other folks are really kind of looking at, the holy grail here is that, you have private blockchain or a blockchain where, you are hashing onto it the function of several different automated contract systems that are nested within each other.
Yeah.
And that, to your point, that nests in there. And then, as we talked about before, the decisions around, resource optimization
Yep.
and operational posture through that automated contract system, would nest in to what the microgrid developer is doing in that system.
Okay, yeah, and that's what we want. So I guess to close it out, if you can all this, to close it out, like part of what we're trying to do here is to engineer the law, or engineer legal instruments, we could say. So I'm going to say this was extremely successful. This is what I would consider good in terms of, and Christian sort of nodding, like these are the types of things that you would expect to see at the beginning of a design process: actors and actions, and some swim lanes, and some key things, some function and flow, and then what we ultimately want to be able to do is compartmentalize or componentize, to modularize, or to like put into blocks, building blocks, these legal instruments and bits of legal process. And so, it's good. It's a nice insight to end today with that. For you could take this kind of PR environment, PR power grid, and then this household, and you could imagine this household thing nesting into a microgrid. And you can imagine a microgrid availing itself of provenance of core legal events with some kind of registry and some sort of audit function with identicons. You can imagine all of this being composed as part of supply chains, or even for that matter, if the whole thing was financed as part of a donation through Inter-American Development Bank or the World Bank, or like with Army Corps of Engineers working. We want to kind of see the way to kind of build as though we were engineers, with the law being part of of the system. So that's probably a good place to end it for today. And then tomorrow we'll come back together with Thomson Reuters, and maybe we can get some legal identity on some of these business entities using Perm ID. Maybe we can pull from some APIs and get the actual price points from like a Pepco or something, and maybe we can like kind of like sketch out some JavaScript or some other simple things to begin to instantiate some of these legal processes within code to have more computational contracts and automatable systems. And then and we can test that and then use that as a launching point for our 3 days together. So I want to thank everybody for this tonight, and then we'll see you tomorrow. Chris, that's